Yes, hello my dear friends. Welcome to all of you to YourPedia. And yeah, hopefully your exam preparation is going in well direction. My dear friends, as you know, Andhra Pradesh Pollution Control Board will come with a huge number of vacancy, especially in the Pollution Control Board. Approx 40 seats is there, and that notification will be released by 15th of August. So that is one of you have golden opportunity to prepare for that exam and serve in your home state. Before that, my dear friends, as I used to say, your PDI is a very popular, especially for the tailor-made module. Means you are basically going to provide the you coaching according to requirement of the exam. Before that your exam, several pollution control board have taken their exam, and you have very successfully completed all these exams previously. Rajasthan, Haryana, Punjab, Jharkhand, Bihar, Uttar Pradesh, all you have completed all these exams. But little bit difference, you will find the question pattern little bit different. Okay, so my dear friends, and one more thing, my dear friends, yes, your notification will come around 15th of 15th of August, and that is your right time to start your preparation, my dear friends, because if you see the history of pollution control board of any state, usually they are going to give maximum 2.5 months, not more than that. Once the notification released and taken the exam, in between only you are getting 2.5 months, sometimes less than that. So it becomes very complicated. Start preparation after the notification will come, it will be very hectic, right? So my dear friends, that is the right time to start your preparation, and your PDI have already launched a dedicated module, tailor-made module for your exam. Okay, and yeah, lot of good opportunity coming to you, especially in the Andhra Pradesh state. Lot of government vacancy is going to be released there, so you have a golden chance. So my dear friends, now without wasting any time, let's start the story. Here we can see, okay, this is your engineering material syllabus, right? 150 question is their technical part, and after in 150 question, every question have 2 marks. That means 300 marks overall technical we can expect. In that, everyone is eligible, like mechanical, civil, chemical, environmental engineer, you guys are eligible for that exam. So first see the syllabus. So here we can say that is the syllabus of engineering material. This is the technical part, and this is a very precise syllabus, my dear friends, very precise. Only here you can see the syllabus: structure and property of engineering material. After that, phase diagram, heat treatment, stress strain diagram for engineering material. And you can see how many topic is there: 1, 2, 3 and 4. In that subject, engineering material, only 4 topic is there which is part of the syllabus. And out of these 4 topic, how many question was been asked? So in the last year when exam was conducted, 12 question was from that segment. 4 topic, every topic consists 3 question and 12 marks. So my dear friends, in less time you can score very good in that segment, and very interesting and impact, you can say, scoring part. This is, you have to be give very less time on that syllabus, and you will be able to get the maximum marks. Before starting to that session, my dear friends, first let's see which type of question is going to ask in that exam. I have came with some PYQ. See, what is the difference between crystalline and amorphous solid? Some option you have. Another question we can say, which of the following is non-ferrous metal? And option you have another question. This is a statement based question, statement and conclusion. Increase in temperature, okay, tempering temperature during the heat treatment. So that question has been taken from the heat treatment, and you have to be answer. Okay, that is question from the phase diagram. That question has been taken from the phase diagram. Okay, and you have to be answer. That is the question from the engineering material, where we'll discuss different types of L-1. So that question has been taken from that segment. Okay, so we can see that is the match column. You can be able to easily score if you have proper studied that subject. That is the question again from the property of material, engineering material, structures and property of engineering material. From that segment, that question, one-liner question. Easily, if you cover the syllabus, easily you could be able to answer that question. That is another question from the stress resistance curve. You have seen one part. Stress resistance curve is a part of your syllabus. From that segment, that question has been asked. Okay, this is the question from the heat treatment. We'll discuss all that in the very details. Okay, that is again question from the phase diagram. So that all are the question, my dear friends, and total 12 question was asked from these 4 subtopics. That's why this is scoring, putting your effort per unit time, that will give you maximum score. Okay, my dear friends. So now let's start our syllabus, and you have seen the first part of your syllabus. I am going to start here. This is structure and property of engineering material. That is lecture number 1. Okay. Lecture number what, my dear friends? This is lecture number 1, L1. So, structure and property of engineering material. My dear friends, in the syllabus, we can say 2 words is there. One is structure, one is what? Structure, and another one is property, right? Properties. And yes, third thing we can see the engineering material. So if I am going to divide whole that part, it will be in the 3 parts. First is structure, then property, then engineering material. Rest and off is English, nothing else. So 3 things. Yes, I will discuss about the structure. That is my part. This is property and this is engineering material. My first question to you, what do you mean by property, my dear friends? That is my first question. Then I will start our syllabus part. What do you mean by property? I know something is coming in your mind. Okay, this is property. Something is coming in your mind. I am damn sure about that. But tell me, what is property? Can you make a comment? See, usually a student is going to be answer, sir, any characteristics of system is called property. Usually, that not my answer, going to be answered by the student. Sir, any character of the system is called property. But that definition is not, my dear friends, well defined, or in fact, complete definition. This is incomplete definition. One thing I want to ask you anything. Listen, that is, one of my AC remote, right? I will ask, what is the color of that? We can say, sir, this is, let's assume black color. Okay, yes, this is black color. Okay, well, my dear friend, this is black color. This is character of the, this remote. Yes. Now, next question I want to ask, tell me how much black it is. How much black it is? Can you answer that? Can you tell me how much black it is? No, sir, I cannot say because I cannot measure. But yes, that color was the character of this remote, but that cannot be property. Try to understand through one example, my dear friends. Another example, I am going to give you one mango, and you have ate the mango, and you are going to be tell, okay, sir, that mango is sweet. And my dear friends, sweet is the taste of that mango, right? Taste is sweet, simply we can say. On the basis of taste, you are going to be judged which type of mango this is. Taste is the character of mango. But again, I will ask, you are telling, okay, sir, that mango is sweet. I will ask, tell me how much sweet it is. Can you answer? No, you cannot answer. Why? Because I cannot measure, sir. For engineer, my dear friends, if I am not able to measure anything, not value for us. This is meaningless to us. Can I say, sir, here, a small force or big force? What is the meaning of a small and big force? You must have to give the numerical value. Okay, 5 Newton force is there, I will tell. Okay, less force. Sir, 5,000 Newton, very high force. So, my dear friends, for engineer, it most important to know the magnitude, right? So, from today onwards, always keep in mind, any character which can be measured. Any character, all those characters which can be measured is called property. The character which cannot be measured, not considered property for engineers. It could be for commerce, could be for art, but not for engineers. So, yes, I can measure temperature, temperature property. I can measure density, density is a property. I can measure pressure, pressure is a property. I can measure volume, volume is a property. I can measure what next? Volume, you can measure it to property. You can measure the strength, strength will be property. You can measure ductility, ductility will be property. You can measure hardness, that all are will be the property, my dear friends. So first thing you have to be keep in mind, the character which are measurable is called property. Now, okay, that's clear, sir, property. Okay. Now, sir, the syllabus is structure and property. Sir, can you tell me, is there any relation between structures and property? Yes, my dear friends, there is a very strong relations between the structures and property. Very strong relations. Or in fact, we can say property is nothing without structures, or a structure is nothing without property. These two are incomplete without each other, and they will be complete only with these two are with each other. Without each other, these two are meaningless. Why, sir? How these are correlated, sir? My dear friends, always keep in mind, structures and property is always related to each other. If I am going to change the structure, property will get changed. If I want to change the property, I have to change the structure. Yes, the structure could be two types, macro and macro. I will teach you later on. It could be two types. One will be macro, another will be the macro. Macro and micro, okay? These two types. The thing that you can see, check, everything, it comes, macro. Micro, if you talk, you cannot see through a necktie. Internal structures could be there. So, my dear friend, just try to understand, in the whole world, everything is made by the atoms, ions, and molecules. You are made by the atoms. These molecules, this marker is made by the atoms. My watch is made by the atoms. In the world, everything is made by the atoms, ions, or molecules. And my dear friends, suppose this is one of the structures you have, and it is made by the atoms, right? It is made by the atoms. They have some another structures. They have some different property. Now same thing is there. Now I am going to be change their structure. I am going to make the thing like that. I am going to make the thing like that. Even it was A, again it is A. But my dear friends, can you tell me these two have same property? Can you tell me these two have same property or different? Obviously, sir, they will have some different property. Why? Because their structure has changed. When the structure has changed, the arrangement of the atoms will change. Later on, I will teach you microstructures or grain structures. I will teach you. By that change in the structures, what is happening? Their grain is changed. Once the grain structure will change, what is happening? Property will totally change. Always keep in mind one thing, my dear friends. Structures and property are very important to each other. They are correlated with each other, and these two play major role in the selection of engineering material. Because if you are going to select the material, you must have known their property in any application, right? So okay, so my dear friends, little bit I am going to zoom that so that it will be easy to remember. Simply here I am going to write everything. The structures and property of engineering material are pivotal in determining their behavior and the performance in various applications. These properties influence the strength, durability, conductivity, and workability of the material, right? Engineering utilize this design and manufacturing of the component of the system. Means these properties going to utilize for the designing of various components. Now, my dear friends, if you talk about overall, material, generally all the material can be classified in two ways. Engineering material can be classified in two ways. One is called crystalline material, another one is called amorphous material. What do you mean by crystalline material? Here we can see, my dear friends, that is your example of crystalline material. We can see in the crystalline material, the arrangement of atoms is regular. They are going to follow the regular pattern. They have fixed pattern. You can see here. So yes, it is very easy to judge their property because everything is regular, pattern is regular. But if you talk about amorphous material, we can see, my dear friends, there is no anything regular pattern is there. Some atom is missed from there, someone is missed for there, here. So nothing, anything regular is there. That type of arrangement is called, my dear friends, amorphous material. So, in the analysis of amorphous material, it becomes little bit tedious, little bit difficult to analyze the overall property. That's why, my dear friends, in the engineering material, usually I am going to focus on the crystalline material because their structures, their property can be analyzed very easily because they have some regular pattern. So, see some point about that, then I will move to the next concept. See here. In case of crystalline material, atoms are arranged in a regular repeating pattern leading to long range order in the structure. Long range order. Commonly example include metal, salt, and many of the ceramic. Now if you talk about amorphous material are arranged without long range order. Example include glass and many polymers comes under the category of that. So sometimes they are going to ask, polymer is which type of material, amorphous or crystalline or both? Obviously it will be the amorphous material. Okay, well, my dear friends, see there, okay, I will come on that bonding. Before moving to bonding, I will come into the crystal structures. Then I will come on all of that. Okay, let's complete that first, then I will come. My dear friends, as I have told you, in the world, everything is made by the combination of atoms, molecules, or ions. Whenever atoms, these two atoms, suppose they are going to meet, so one force of attraction will between these two or not. And this force of attraction will play very crucial or major role in the selection of the property of material. Right? Suppose, let's assume one thing I want to tell you. These two atoms, and there is a very strong, we can say, force of attraction between two atoms. Very strong force of attraction. Can you tell me it will be ductile or brittle? Can you tell me it will be ductile or brittle? Anybody of you? First of all, I might possible you don't know what is ductile and brittle. Just listen, my dear friends, I want to tell you that is mechanical property. Ductile, brittle, hardness, that all comes under the category of mechanical property. Ductility is nothing but it is that property of the material because of which, my dear friends, you are capable to draw it in the wire form. If any material is not ductile, you cannot convert in the wire form. Like, my dear friends, wood is a brittle material. You cannot convert it in the wire form. If you talk about aluminum, you talk about copper, you talk about metal, these all are generally ductile in the nature. But if you talk about wood, you talk about marker, you talk about that pen, you talk about cast iron, that all comes under the category of brittle material. Brittle material is not going to be significant change in their length, before that it is going to fracture. But if you talk about ductile material, so before going to fracture, they will give significant change in their length. And one more thing, my dear friends, brittle material never going to tell you, okay, it is going to break. It suddenly break. Like you have a marker, you have a pencil. If you have remembered in your childhood, you used to pencil to the right over the slate or anything. Even in your college day, nowadays even it is going to use the marker, pencil to write over the board. That is brittle material, because that is going to be breaking down suddenly. But if you talk about steel, if you talk about copper, you talk about aluminum, they are before going to be fracture, it is going to sign, it is going to indication, okay, I am going to be fracture. So that is the one of the advantage of the ductile material. You can recover, suppose it is going to break, so it is going to break. Before that, you have a sufficient time to recover that break, you can recover their shape. So that's good. So my dear friends, now see, if the force of attraction between these two is very strong, so can you tell me it is easy or difficult to change their length? Suppose this is one of the object, it is made by the combination of atoms having a strong force of attraction, if you apply the force to change their length, it will be very difficult, because force of attraction between the atoms is very strong. Yes sir, that means that type of material comes under the category of brittle. It will be very tough to make it ductile. But same way, my dear friends, same way we can say this is one of the object, it is made by the combination of atoms, but the interatomic force between the atoms is less, so it is easy to change their length, so it will be the ductile. It could be the ductile, I am not telling it will be, it could be the ductile, it can be ductile. Right or no? So yes, so we can say these interatomic force play a major role to selection of particular material of a property. So my dear friend, that's why I am going to discuss some atomic bonding here, then I will come. Since here we talk about the ionic bond, you might well aware about the ionic bond. This is basically transfer of electrons. So ionic bond involving the transfer of electrons between atoms, resulting in oppositely charged ions that attract each other. Ionic bonding is typically found in ceramic. And yes, what the most important you have to be keep in mind, since sir ionic bond is strong sir, so it will be the brittle. Since it is bond is strong, so it will be the brittle. So whenever you have ionic bond in the material, we can say sir it will be the brittle in the nature. Right? Okay. So here we can say everything I have going to read right here. Na plus Cl minus, simply we can say this is one of the atom, this is non-metal, and metal have sufficient number of electrons, so in fact free electrons, so and they are going to make a bond and becomes the ionic bond. Okay. Next, you talk about covalent bonds. So this is the sharing of electrons. Now, this is the sharing of electrons. This bond is directional. That is the key point. Sometimes they are going to ask. This is the key point. That is a directional in the nature, and obviously it is a strong, high strength of materials such as diamond and the polymer. Always keep in mind that thing is going to be asked in, Rajasthan. I have remember that question was asked in case of diamond and polymer, which type of bond is going to be appear? Ionic, covalent, metallic, or van der Waals? It will be the covalent bond, right? So try to keep in mind. Now in the question session I will talk about that. This simply we can say this is the covalent bond sharing of the electrons, and the bond is going to be formed there. Now if you talk about metallic bonds, so involve the sharing of free electrons that moves throughout the metal. This bonding leads to high electrical and thermal conductivity, ductility and malleability, all that. Copper and aluminum, they all have. This is van der Waals force, which is weak in nature. Van der Waals force is what? Weak in nature, very weak we can say. See, this is negative and negative is there. So they are going to be repelled and the bond is going to form like that. So it is comes under the category of van der Waals, that is weak in the nature. Okay. Now I am going to be talk about crystallography and crystal structures. That is the another part, crystal structures or crystallography. So crystal structures refers to orderly arrangement of atoms, ions or molecules in a material. It influences material properties such as strain, ductility and thermal conductivity. Understanding crystallography is essential for predicting how material behave under the stress or heat. That's most important, my dear friends. See, this is so simply where you can say material with crystallographically have some atom arranged in a repeating periodic pattern. This arrangement defines whether the material is crystalline or amorphous, as you have discussed earlier. Here will be the short range order. Now let us talk about different types of crystal. Different types of crystal we can say. One is called body centered cubic. What do you mean by body centered cubic? Just listen, before moving to that, I want to tell you one thing, one point about Vinit cell. You know what? Vinit cell. What is this Vinit cell, my dear friends? If I will ask, your body is made by what? What is the smallest part of body? Obviously, we can say cell. Cell is the part of body by the repeating arrangement of that cell, your body is going to be formed. In fact, any body has been formed by the combination of cells, especially you talk about living organism. Same here, my dear friends. Vinit cell is nothing but it is that smallest element, especially in the crystal structures, when they are repeating in a three-dimensional or regular arrangement or regular repeating of the Vinit cell, I will get one of the perfect crystal structures. Usually, I used to say one thing. Suppose you have to make a wall, right? You have to make a wall, right? How you are going to make? Obviously, you can say, sir, I am going to put brick and cement and all that. Brick, after that another brick, means by the regular combination of brick I am getting the wall. So for a while we can consider the brick is one of the type of unit cell. We can understand like that. So unit cell is nothing but, my dear friends, it is the smallest things. By the repeating arrangement of that I am going to get the some crystals, and that is called different types of crystal you are getting. So unit cell, generally if you talk about unit cell, generally if you talk, my dear friends, this is the shape of unit cell. This is U shape of unit cell. Okay, if you talk about in unit cell, what is happening? Generally, the atoms is going to be takes place at the corner. Here we can say the atoms is at the corner, and some fact it is also called simple cubic. This is also called is what, my dear friends? This is called simple cubic. If you have remembered a little bit, we can say this is the simple cubic structures. Here we can say this is called the body centered cubic. In body centered cubic, what is happening, my dear friends? See, this is one of your cube. Little bit I'm going to be zoom out. This is one of the cube, and we can say in the cube one body center will be there. That is whole center of the cube, and if the atoms is that point, this is called body centered cubic. Now this is called face centered cubic. In face centered cubic, what is happening? Atom is at the face along with corner atoms. Atoms will be at the face only, face along with corner, atom will be on the face also. This is called face centered cubic. This will be called is what? Face centered. You know, whenever you are going to be draw any cube, right? See, any cube, if you are going to be draw like that, suppose this is one of your cube, so you know how many faces will be there. Obviously there will be 6 faces now. Here one atom, another atom, like that. Let's assume A, B, C, D, E, F, G, H. So how many faces? You can say in a cube, how many faces there, my different 6 faces. One face you can say like that. This is one of the face, right or no? Yes, this is one of the face. This face have some center. So suppose one atom is there. So this is one of the face. Similarly, you can get another face also, my dear friends. Let's assume this is one of the face. And there will be their center also. And one atom is at this center. So you can say along with corner you are getting one atom at the face of its center. Center of all the faces. This is called face center. Similarly, we can understand this is one of the face. Or no? This we can see one of the face, and at the center of this face one atom is there. So this will be face centered. Similarly, another face we can see here. Let me choose which color. Okay, that color is visible. This is one of the face and one atom is there. So, and same here we will get. So how many faces is there? 6 faces there basically, and all the face atom is there. So this is called face centered cubic. Clear or not? So you know, in all the case you are seeing the arrangement of atoms is different. Nah? So obviously all the structures have different properties. BCC will have different properties. FCC will have face centered cubic have different properties. Simple cubic have different properties, because arrangement of atoms is different in all that case we can see, right? So here simply we can say written here body centered cubic. What the body centered cubic? We can say atoms are located at the corner and at the center of tube. Material with the BCC structure such as iron at room temperature. That question was asked again in Rajasthan. Iron at room temperature, what is their structures? It will be BCC. Even one chapter is their phase diagram, that is the part of your syllabus, where I will discuss much more about the this iron carbon diagram is there. I will discuss much more about that, because especially iron have one property that they can show the different structures at different temperatures. This is called allotropy of the material, because they can show different structures at different temperatures. So obviously their property will be also different at different temperatures, and they are typically hard but brittle. This will be hard and brittle due to less closely packed in the nature. Everything is the question. Whatever I am going to be highlighted, everything, every word of that is question has been asked in different exams. So try to remember, BCC is brittle. B for BCC, B for brittle. Keep in mind. So body center is brittle due to less closely packed nature. Here we can see all that diagram. Next we talk about face centered cubic, that you have seen above. Atoms are located at the corner and the center of each of the face of the tube. Material like, keep in mind, aluminum, copper and gold have these structures and are generally more ductile. Because of atoms are more closely packed. Because atoms are more closely packed. So it will be the ductile. Similar way, we can see the hexagonal close pack. Atoms are packed tightly in hexagonal arrangement. Material like titanium and magnesium have SCP structure and often exhibit high strength but less ductile compared to face centered cubic. Now I am telling you, you may ask, sir, what is the main cause to what are the different factors on which the ductility is going to be different. There are the various factors. One is dislocation moment. Higher the dislocation moment, more will be the ductility. What is dislocation? A little bit I will teach you in upcoming session. Even in the today's session also I will discuss about the dislocation, but that depends upon different factors. Higher the dislocation, more will be the ductility. Now even you can ask, sir, what is dislocation and why this is happening? Then it becomes much more core for the mechanical. So just try to remember the result that I am telling you. Just okay, because question is going to ask very straightforward. You don't have to do research in the mechanical segments. Little bit you have to be knowledge all about that. So my dear friends, now next talk about the coordination number. That's another important coordination number. It is the number of atoms touching a particular atom or the number of nearest neighbor of that particular atom. Simply coordination number is telling one atom is going to be touched, how many different atoms or how many different neighbor atoms they are going to be touched. That is called their coordination number. Like, so if you talk about coordination number in different case here, my dear friends, if you talk about simple cubic, in case of simple cubic, please remember coordination number is 6. In body centered cubic, coordination number is 8. Just try to remember. In face centered and hexagonal, coordination number is 12. So remember or not, my dear friends? Try to remember. In case of hexagonal and face centered cubic, coordination number is 12. In case of BCC, it is 8 and simple cubic is what? 6. How it is coming? We can just try to understand that value because they are going to, this will be some 3D diagram. How much it is going to be touched, according to that you are going to be judged. This is, you can see the hexagonal, take any and after that you could be able to judge how many different atoms they are going to be touched. Now, my dear friends, sometimes what is happening is, that was the question has been asked in Jharkhand. What is the relation between the A is the side of the tube and R is the radius? Suppose I am telling you this is one of the face that I am going to be taking. So this is the atoms and this is another atoms, okay, and their radius is what? R, and side is A. So A is equal to what? 2R. That was the question has been asked in one of the exam. I think Jharkhand it was. What is the relation between A and R in case of simple cubic? It will be A equal to 2R. Here we can see that is the one of the segment that I am going to be see here. This is R, and you can say even in only one 8 portion is involved. One atom only 1/8 portion is involved in simple cubic. So A equal to 2R. Similarly, my dear friends, if you talk about BCC, keep in mind, I am telling you here, if you talk about BCC, so BCC, it is happening here, simply we can say A is equal to 2 root 2. Okay, from there what you are getting? 4R upon A square, and this is going to be 16R square. From there we will get the relation. Here we can say BCC is 4R upon root 3. My dear friends, see that, try to remember all that is most important. One question we can expect from that segment. Simple cubic A equal to 2R, BCC A equal to 4R upon root 3, face centered A equal to 4R, or in fact we can say 2 root 2R. Okay, so here try to remember A 2 root 2R, here it will be the 4R upon root 3, A equal to 2R. Simple cubic A equal to 2R, face centered 2 root 2R, body centered 4R upon root 3. You know how you can remember? In BCC, you know B is looking like 3 na? So BCC, B is looking like 3. So just keep in mind 4R upon root 3. That is some way you can use technique to remember all that value. If you talk about effective number of atoms, so effective number of atoms in simple cubic, you know my difference. See here, if I will ask what is the effective number of atoms, right? Even we can see here coordination number, effective number of atoms. So in case of body centered cubic you talk, in case of simple cubic you talk. So in case of simple cubic, atoms is only at the corners, right? Here, only at the corners. So always keep in mind 1/8 into 8. that will be the effective number of atoms in BCC, sorry, in simple cubic. Effective number, how much effectively involved? You can see, sir, 8 atom is there, but these all are not effectively involved, because another part of that atom involved in another unit cell also, in another part of unit cell. So it will be 1 upon 8 into 8 is coming out to be 8. If you talk about body centered, so corner atom is 1 upon 8 into 8. Body centered, they are fully involved in only these unit cell. So it will be plus 1. So body centered will coming out to be, they are going to box, so it will be the 2. If you talk about face centered cubic, so in face centered 1 upon 8 into 8 plus 1 upon 2 into 6, because our phase, another row, they half of the involved in that phase and half of the atom involved in another phase. That's why half you are going to be take. So it is coming out to be how much, dear friend? 4. So always keep in mind, effective number of atoms in face centered is 4, effective number of atoms in body centered is 2, okay, and effective number of atoms in simple cubic is what? 1 is coming. Effective number of atoms in hexagonal, it is coming out to be 6. Hexagonal is coming hexa, even you have remember 6 na, hexagonal itself name indicates 6. So if atoms per unit cell or effective number of atoms, here it will be 6, 4, 2, 1, 1, 2, 4, 6, 1, 2, 4, 6. Coordinates number 6, 8, 12, 12. This is APF. APF is what? Atomic packing factor. This is 52, 68, 74 or 74%. Try to remember that value. Later on I will see that all that point. Even in the upcoming session, little bit we'll see about what is the APF. APF is basically indicate, my dear friends, how much portion of the unit cell, what the APF indicate. APF is 52%. What is the meaning of that? Meaning is that 52% of the volume of the unit cell has been engaged by the atom. You know, suppose that is one of the unit cell now, my dear friends. This is one of the unit cell, huh? This is one of the unit cell, corner atoms like that, okay. Now I will ask, how many volume of that unit cell has been occupied by the atoms? That information is given by APF, atomic packing factor, right? If 52% is there, that means total volume is AQ. Out of AQ, 52% portion of that volume has been occupied by the atoms. Rest 48% is vacant. If the APF is 68%, the meaning is that total volume, 68% of the total volume has been occupied by the atoms. The rest space of that unit cell is vacuum, nothing else is there. And what the vacuum meaning? Means you can ly the element there. You can ly now. If the space will be there, then only you could be able to ly. Now we can ask, sir, maximum is 74%. Why not 100%, sir? Could be possible that APF would be 100%? That never possible, my dear friend. Never. Why, sir? Why never possible? My dear friends, if you have remember, atoms, what is the shape of atoms? This is a spherical now. Have you remembered the Avogadro's? So the shape of the atoms is what? A spherical. If the shape of the atoms is spherical, can you tell me, whenever 4 atoms is going to meet, one space will be there. Always one space will be there. Huh? This space will be the vacant. This space, like if you have 4 cricket ball or football, you have a 4 cricket ball or football. Whenever 4 football or cricket ball is going to be, matched, one vacant site you are getting. Right or no? So APF can never be 100%, my dear friends. BCC example in real life, you can understand. BCC real life example. Suppose you have a 4 football. You have 4 football. Okay. And meet that 4 football and put 1 cricket ball over that. Put 1 cricket ball over that. This is one of the cricket ball. Huh? 4 football, put 1 cricket ball over that. Now again, over all that, again put 4 football. Again put 4 football. Again put the cricket ball. And the structures that will get after repeating that thing, this comes under the category of what? BCC, body centered cubic. We'll get what? BCC, body centered cubic. Now my dear friends, this is called defect in crystal, or we can say the crystal defect. A defect in the crystal, or we can say crystal defect. Whenever I am telling defects, the what first thing image is formed in your mind? What first image formed in your mind? Something negative cheese, sir. Something negative image is going to form. Defect means something negative cheese. That should not happen. My dear friends, if you talk about defect in the crystal, so sometimes intentionally I am going to produce, sometimes unintentionally it is produced, sometimes intentionally, sometimes unintentionally. How unintentionally? Suppose this is one of the objects in this atoms is there like that. Now I have put that object over the in the sunshine. So from the sunshine, the sun rays is coming over that. If the sun rays is coming, might be possible the atoms will get the energy and they may get distorted. They may leave their parent site. So that is the unintentional defect. If you are going to be hammer over that, could be defect. Now sometimes I am going to produce intentionally. My dear friends, you might have listened the L-1 of element. I am going to produce defect there intentionally to change their property, to get the desired property. I am going to produce defect in the base or parent matter by alloying of element. Alloying of element itself a defect. Right? Now, what you have to be remembered that leave my dear friends volume. Actually, defect will be three types: point defect, line defect, and surface defect. If you talk about point defect, so please try to remember at least name. There are five or five defect: point defect, vacancy, interstitial, substitutional, short key, and Frankel. If you talk about line defect, so edge dislocation, screw dislocation. If you talk about surface defect, grain boundary and twin boundary. One question was there, I think in the Bihar or Punjab, I think it was question. Question was edge dislocation with which type of defect? Option A point defect, option B line defect, option C surface defect, option D or none of the above. Like that option was there. What we can say? We can say sir, edge dislocation is a line defect. So that type of question they are going to be asked. Even you have seen initially before starting the session, I have seen you some question very easy and straightforward. Some question has been asked a little bit difficult also, but most if the straightforward. So just try to remember their name at least. The rest I am going to discuss one by one, but try to remember. Vacancy, interstitial, substitutional, short key, Frankel comes under the category of point defect. Edge dislocation, screw dislocation comes under the category of line defect. Grain boundary and twin boundary comes under the category of what? Surface defect. At least try to remember their name. Now I am going to discuss one by one. First is point defect. These are error in the crystal structures where atoms are missing or displaced. This include vacancy, interstitial and all that. Point defect means that type of defect which is going to produce at a point. That type of defect is called point defect. First you talk about vacancy. Their name is can indicate vacancy. Vacancy means some atom has vacant. You can see. And that we can see that was the space which is totally that is not occupied by the atoms. The atoms which was at that site, it is removed. Here we can see another diagram I have came with you. See my dear friends, that is one of your perfect crystal, but this is your vacancy point or vacancy suffered crystal in which one atom from that segment has been reduced, has been removed from that point. So that comes under the vacancy defect. So what is the effect of vacancy defect? Obviously we can say the density will decrease, right or no? Another property will also affect. So it causes decrease in the density of the material and can affect the material mechanical and thermal property, obviously. Now if you talk about interstitial defect, what is interstitial defect? An interstitial defect occurs when an atom occupies a space interstitial site between the regular position in the lattice. Meaning is what, sir? Interstitial occurs when the atoms occupy a space interstitial between the regular position in the lattice. See my dear friends, that we can say this is your iron, this is your carbon. In that what is happening, whenever four atoms is going to meet, my dear friends, whenever four atoms is going to meet, one vacant site will be produced. One vacant site will be produced. And on that vacant site, if one of the atom is going to be sit at that position, that is called interstitial defect. And my dear friends, that I am going to produce intentionally to get the desired property. Have you listened the name of steel? If you are mechanical or civil guys, you must have aware about the steel, no? So steel is what? That is one type of that interstitial defect, in which this is your atom and carbon is going to be occupied at interstitial site. That's why it comes under the category of which type of defect? Interstitial defect. So it was question has been asked one time. Still, which type of defect is found? It was like that. Substitutional, vacancy, like that. It was something question. So we can say it is substitutional. Interstitial defect is going to be found, right? And because of that, what is happening, my dear friends? Obviously, atom is little bit distorted. It is coming to that side, so little bit distortion can be found in the atoms, or in the crystal. So here we can say once they will come, little bit it get distorted. So here effect we can also see. But yes, it increases the density. It increases density. Yes, it increases the material density and may cause distortion in the lattice, affecting the material property. Next, we talk about substitutional defect. So substitutional defect, one type of atom in a crystal lattice replaced by different types of atoms of their different size. Here we can see this is comes under the category of they have removed one of the atom and they are going to be occupied that side, so it is called substitutional impurities. All that impurities you can see in that diagram. So what is the effect of that? Change the material, electrical, mechanical or thermal property depending upon the nature of substitution. They can change all that. Now you talk about Frankel defect. What is Frankel defect, my dear friends? What do you mean by Frankel defect? What do you mean by Frankel defect? Anybody? So simply we can see here Frankel defect occurs when an atom or ions displaced from its normal lattice to interstitial side. See, my difference. Initially it was something like that. No, that was one of the atom. This is positive ions. They are going to be leave their side and going to be occupy the interstitial side. So that type of defect comes under the Frankel defect. More clarity we can see there. Initially this atom was there, Na plus Cl minus, you are going to be sodium chloride. So Na is there, they have leave their side and going to occupy the another position. That is called Frankel defect. What effect? What is the effect we can see by the that of that defect? Obviously we can say some distortion could be there. Some distortion could be there, but yeah, overall density will not change because they are going to be in interstitial side. Right, so distortion could be there, but overall density no change. So here we can say commonly observed in the any crystal and cause slight distortion in the crystal structures. Right, obviously. Now talk about Schottky defect. My dear friends, you can see here Schottky defect occur when the equal number of cation and anions are missing from their lattice site, creating vacancy. Simply we can see here. See here. This is your visible or not? okay. See here. See, this is one of the negative ions. This is your positive ions, right? And they have leave their side. That is called Schottky defect. In case of Schottky defect, the density will change. It will decrease its impact because they are going to leave their parent side. Now, if you talk about, my dear friends, what is difference between these two, Schottky and Frankel? You talk about. So here. Schottky and Frankel defect. So Schottky defect, ionic crystal arises when equal number of cation and anions are missing from their normal site, resulting equal number of cation and anions vacancy, decreases density of the crystal. But if we talk about Frankel defect, ionic crystal arises when some ions, generally cations. Now why generally cations? Always keep in mind, my dear friend, the size of the cations is less than that of anions. So it is easy to go cations, not anions, because size of the anions is higher. So it cannot move from their lattice side. But if you talk about cations, their size is less, so they can move. So always keep in mind that point also. So my dear friends, so here we can say this defect maintain electrical neutrality crystal but reduce density, especially if we talk about Schottky defect. Next, you talk about dislocation. So what dislocation? Dislocation occurs when there is misalignment in a row of atoms, and these important because they enable material to deform plastically, contributing to their ductility. My dear friends, Always keep in mind, even in the interview sometimes, not in general, but sometimes they are going to be asked why the FCC is more ductile. So because in FCC, dislocation is more. Higher the dislocation, more will be the ductility. Always keep in mind, okay? Later on, if you are from the mechanical, I will teach you in some upcoming batch if you are going to be joined. So, meanwhile, if you talk about dislocation, my dear friends, see there. Here we can say this is your edge dislocation, this is your screw dislocation. In edge dislocation, here we can say all the atoms has been vacant side from there. No? So that is line defect. No? This is line defect. So this is called edge dislocation. If you talk about a screw, here we can say they have tilted their dislocation like that, move. So this is called a screw dislocation. So just always keep in mind that all comes under the category of what? Line. They are going to form a line. Even here it is going to form the line. So it is called what? Line defect. Now grain boundary. These occur at the interface between the different crystal grain. In porous crystal material, they play a role in material strength and behavior under strength. These play a role in the material strength. Always keep in mind, main point. Grain boundary mainly responsible for the strength of the material. Grain means, there are different types of grain. Different types of grain are there, like core grain, fine grain, equinox grain. Different types of grain is there, my dear friends. Grain means internal structure that you cannot see through the naked eye. Here we can say, this is, and the different grains which is separated by one line. So it is over the surface. That's why it is called grain boundary, and it comes under the category of surface defect. Here even we can see, my dear friends, this is one of the grain, this is another grain, and the line which is going to be separate these two comes under the category of grain boundary. Now it is going to be separate different types of grain, and it is happening over the surface. That's why it is called surface defect, and it impart their main property in the strength. Okay, so my dear friends, all that unit cell we have already discussed. Let's take all that you have seen. Unit cell regular arrangement. Okay, now different types. Okay, I will teach you that in upcoming session, don't worry, I will teach you that thing. Now my dear friends, whatever I have teach you, try to solve some question on that. See, that was your previous year question which was asked. What is the key difference between the crystalline and amorphous solid? Some option you have. Crystalline solid have ordered arrangement of atoms, while amorphous solid lack wrong range order. Yes, that was the right answer. So first point is the right. That is your PYQ, which was asked in your exam previously. So A1 is the right answer. What will be answer of that question, my dear friends? Question number second. That is your again your PYQ. What is the average number of atoms per unit cell in a simple cubic? So simple cubic, simply we can say 1 upon 8 into 8. It is coming out to be 1. So simple cubic they have asked, might be possible in upcoming exam, they may ask about effective number of atoms in body centered or face centered or hexagonal closed pack. They may ask in upcoming exam. Okay, now come to the next practice question. Now this is your practice question. This is your practice question. What type of bonding involved in transfer of electrons between atoms? So atoms, that was easy question, easily you are able to answer. Ionic bond. Okay, come to the next question. Which of the following material has body centered cubic structures? Aluminum, copper, titanium, or iron at room temperature? Just starting of the session you have discussed about that. Which of the following material have body centered cubic? Yes, iron at room temperature. A for apple is the right answer. Come to the next question. Answer that question. What is the key characteristics of material with face-centered cubic structures? They are more ductile due to closer packing of atoms. They are generally harder than BCC material. They exhibit low density. They are less ductile due to their atomic arrangement. What will be answer, my dear friends? Tell me, if you have gone through whole the session, please answer that question. Yes, they are more ductile due to closer packing of atoms. So A for apple is the right answer. Come to the okay, that you have given. Answer that question now. Which defect occurs when atom is displaced to an interstitial site in the crystal? Which defect occurs when atom is displaced? Vacancy, substitutional Frankel short key, displaced to an interstitial. So it directly called which type of defect? Displaced to an interstitial site. Tell me the answer. I know you are getting confused. It will be the Frankel. In the Frankel defect, both type of defect you can observe, vacancy and interstitial. This both thing is happening in case of Frankel, na? So correct answer will be Frankel defect. Come to the next question. Getting na? Okay. Yes, you have Frankel defect. Why you are confused? Frankel. See there, Frankel defect. See clearly mentioned in Frankel defect creating both vacancy and interstitial. So atom was there, it is going to be removed from there. So here vacancy will be there, and it is going to be come to the interstitial side. So interstitial defect both could be there. Here we can say there is a vacancy now, and it will go to the interstitial side. So both type of defect you come observe. Okay. Then what is the question number next? What is the impact of interstitial defect in the crystal? Impact of interstitial defect. It decreases the density of the material. It increases the material density and may distort the lattice. Okay. Interstitial. It has no impact on the material property. It improves the material thermal conductivity. Interstitial it increases material density and may distortion lattice. Yes, interstitial defect B for Bombay. You know iron this is like that. Okay, like it is something like that. This is your iron and carbon is coming at that point. So density increases now. Carbon is coming there. So density increases and some distortion we can get. So B for Bombay is the right answer. Come to the next question. Which crystal has the highest number of packing factor among the following? So highest number of packing factor. Highest number of packing factor. FCC. Yes. That's because it is a more ductile. That's why. Come to the next question. The crystal lattice refer to arrangement of which of the following material? The crystal lattice refer to arrangement of which of the following material? What will be answer of that question, dear? Atoms, electrons, molecules, or ions. So crystal lattice refer to arrangement of which of the following material? So it will be atoms, So A for apple is the right answer. Atoms is the correct. Come to next question. In which material structure do atom most tightly packed arrangement? Most tightly packed. What will be answer of that? Most tightly packed. Anybody? What answer? Obviously, we are going to give the answer, hexagonal now. Hexagonal is the right answer, dear. Very good, very good. Okay. So hexagonal close pack itself. Yes. Come to the next question. I am going to share that PDF. There will be one link in the description. We can get that PDF in that WhatsApp link. Which of the bonding direction and strong contributing to the highest strength most material like diamond? In the diamond, which type of bond you are going to be observed? Covalent bond. That was the question has been asked. Here we can see the strong directional. Directional we can even find only in the covalent bond, not in the ionic, metallic, and van der Waals. So diamond and have what? Covalent bond. Answer the next question. Which of the following bond are responsible material like graphite and polymers? graphite and polymer. Which type of bond you are going to be get? Anybody answer that question? Answer that question. Which of the following bond are responsible? Material like graphite and the polymer. Yes, graphite and the polymer. Covalent bond? Yes. So I think again you have given the right answer since you have gone through whole the session. That's why. Answer that question. What will be answer of that question, dear? What is the result of Schottky defect in the ionic crystal? Schottky, it increases material electrical conductivity, it causes distortion lattice, it maintains electrical neutrality but does not affect the material density, it improves the strength of material. What answer? Maintain electrical neutrality but does not affect the material density. It improves the strength of material. It causes distortion lattice and reduce density. It increases the material electrical conductivity. B for Bombay is the right answer. Yes, right. Since missing, so density will decrease. Okay. A, B, C, alpha, beta, that all are A, B, C or equal alpha, beta, gamma or are equal to 90. So this is called is what? Cubic structures now. This is called is what, my defense? It will be called as cubic structures because all are equal and all that. Answer that question. What type of defect occur when atom missing from its regular lattice site? Missing means vacancy defect na. Missing from regular lattice site, the answer will be the vacancy defect. Yes. Answer that question. What does the presence of grain boundary in the material contribute to? Presence of grain boundary in the material contribute to. It increases electrical conductivity, high plasticity, increases material strength under stress, better thermal conductivity. So what will be answer? C for Chennai, increase material stress under the stress. I have earlier told you grain boundary directly regarding to the strength. So simply you are able to answer if you have gone through whole the session. So C for Chennai is the right answer. Come to the next question. What type of bond occur when free electrons move throughout the metal? Free electrons move, so it will be the metallic bond. Answer the next question. In which of the crystal structure atom have hexagonal arrangement? That is a very simple question. C for Chennai will be the right answer. Hexagonal itself name indicate. Okay, in which of the crystal system A not equal to B, not equal to C, alpha not equal to beta, not equal to gamma? It will be the triclinic. What it will be? Triclinic. Not side equal, not angle. Triclinic is the right answer. Next, which of the following bonding type leads to brittle material commonly found in ceramic? In ceramic, which type of bond? Ceramic. Just now you have seen ceramic ionic bond is there. So correct answer will be A for apple. Ceramic question was asked in your exam also regarding to ceramic. Yes. Which of the crystal characterized by atoms located at the corner and at the center of each face of the cube? Center of each face, so it will be the face centered cubic. So my dear friends, that all about the session, right? Hopefully next whenever I will come, I will discuss the different mechanical properties. Okay, I will discuss different types of mechanical properties stress strain in the upcoming session. So my dear friends, now as I told you, our batch is already going on. You can join that also, and to get that PDF, one description, one WhatsApp link would be there. We can join that and get any information regarding batch, test series, or any doubt you have. You can ask about your doubt, whatever you have. Yeah, okay. So thank you, and yes, good luck. Hopefully, we'll meet you in a live.